Hello, everyone. Oh, it's a bit loud. Welcome for joining this session. So the session will be about microservices and GraphQL. So I will show how you can use Node.js microservices together with GraphQL in multiple different ways to make best use of these services from your front-end client. So who's this for? I think it's also important to state. We'll be using Node.js microservices, but it doesn't mean you should actually use microservices. I've seen plenty of companies ending up with something like this. So at some point, the architect or maybe some of the developers or a manager thinks they should adopt microservices, while in theory, their monolith is actually perfectly fine. So make sure whenever you start using microservices, you actually have a need for it. And it's not something you just want from a architecture perspective without having the actual need for it in terms of performance or having the need for it in terms of separation of concerns. Because the biggest thing I see for microservices, it's really easy to have separation of concerns for different teams or different business domains. And if you don't have these needs and you're only looking for performance, always try to see how you can scale your existing monolith, maybe horizontally, to make sure you still have the performance benefits that you're looking for. Because I've seen a lot of microservices done wrong, either by having no overarching architecture or by having no clear separation of concerns. So you maybe end up with something like this, and then your big monolith taking all these containers in there might have been a better solution after all. But if you do have microservices, let's have a look how you can use them together with GraphQL to get the most out of them. A little bit about myself. So my name is Roy. You can find me on Twitter with the handle @GetHackTeam. I tweet a lot about GraphQL, also React, TypeScript, JavaScript, all these technologies, as I've been working with them for the, I think past 5 or 6 years. I also wrote some books about GraphQL, also React. And you can find more talks about me on YouTube as well. Currently, I work for a company called StepSend, which I will tell you more about later on. So what do you already know about GraphQL? Are there people in the audience that are using GraphQL? No? Okay, so we have 2, 3, maybe. So let's tell you a bit more about GraphQL and why it's perfect for microservices. So I often think GraphQL is perfect for microservices because it gives you a separation of concerns. So with GraphQL, you typically have one endpoint instead of a lot. If you're now using REST, you probably have maybe tens or maybe even hundreds of different endpoints that you need to use within your front-end application. Maybe you also need to combine them. And sometimes even to fill one page in your UI, you even need to call different endpoints all at once. And with GraphQL, this is different because you have just one endpoint and you have that separation of concerns, which I can show you more about later. And mostly because it's all about graphs. So in GraphQL, typically every service will have their own graph. So if you have a monolith now that uses GraphQL, it will have one graph taken together all those different parts of your monolith. And the same can be said for microservices. So if you now have a REST API that has 10 different endpoints, you probably are linked to 10 different tables in your database. Or maybe it's a bit more, maybe it's a bit less. But what's typical with REST APIs is that every database table has its own endpoint. And with GraphQL, instead of having an endpoint per database table, you typically have one type, or maybe multiple types if it's a large table, that refers to this endpoint. And then from GraphQL, you can mix and match all these different types into one query, which I will show you later. And this is very much related to microservices, because if you have one endpoint that is linked to one database table, in GraphQL, it will be one graph per database table. And for microservices, you typically have the same separation of concern. Your microservices probably are spanning multiple tables in your database, or maybe just one, or they have their own database. But typically, microservices are domain-based. So they do one thing, and they tend to do it very well. If you currently have a microservice that is using, that's spanning multiple domains, think about if it's actually a microservice or just a small monolith. So this is something to also take into account. And this can be an example of your microservices setup. So assume you have a front-end client and you have multiple microservices. So from your client, you're probably talking with multiple microservices, unless you have some sort of API gateway or API mesh or service mesh in there that will bring together all your different microservices. And each service has its own domain, which is very important because, as I said, if you truly have microservices, Every service will have their own domain. If it's not the case, think about it if you're not running multiple small monoliths, which is something I see a lot with different companies. They tend to start at one monolith, they split it up into different microservices, which are actually just smaller monoliths, and then they will end up in some situation where they're actually maintaining multiple monoliths instead of one monolith, and the microservices aren't really separated. So if we look at this example we have here, so we have one client talking with multiple services, each have its own domain. It will probably look something like this if you give the domains a name. So you can say you have an authorization service, which is the microservice taking care of your authorization. Then you have a service for your users, which has all the information about your users, and then you could have one for post. And this could be a typical setup for maybe any CRM or any blog platform, because you can also change out posts for products or whatever type of service you're building. So typically, when you're interacting with a microservice setup like this, you would start by using the authentication service to get a token, because every user should have its own token. So you should send a request to get your token, and you will receive the token back. And then any of these microservices will actually need your token in order to give you a result. And sometimes you also see microservices that have an authentication service per microservice, which is something you can do, but it can get quite frustrating at the end. So typically I would say you have an authorization service that can help all your other services authenticate. But as you see, you will need multiple requests in order to fill your data. You need to get the token at first, then you will need to get information about users, and then if you also want to see posts, maybe per user, or maybe you want to get posts first and then link a user to post, it means you will need to do multiple requests. As you can see here, it's 3, but I've seen setups where it's even more. Which is also fine because these are all domain-based. And then, if you want to turn these microservices into GraphQL, every service should have their own graph. So as I said before, in a REST setup, typically every microservice will have their own endpoints, or maybe set of endpoints. In GraphQL, every microservice will have their own graph. Which means if you look at this setup again, you can say every domain should have its own graph, and thereby every microservice should have their own graph. And it's typically fine if you don't already are implementing GraphQL for your microservices, because you can build this graph on top of what you already have built in REST. But let's suppose every microservice will have their own graph. This will also mean instead of using REST, you can interact with these microservices using GraphQL. So instead of sending a typical REST request to an endpoint or to a set of endpoint, you can send just one GraphQL request. And by having a graph, it's also mean that every team or every microservice can take care of their own types that they've defined and of the queries that they will allow. And then the nicest part on why you should actually use GraphQL if you set up like this, you can combine all these different graphs into one schema. So maybe with REST you already have a data layer or an API gateway or an API mesh that will help you bring together all these services. With GraphQL it's typically the same. You can have a GraphQL data layer or a GraphQL API gateway that will bring together all these different services. And instead of meaning you would need to take all these endpoints and stitch them together in one REST API gateway, you can typically merge the graphs. So all the graphs will become one large graph. And there are multiple names for this. You have maybe heard about a super graph or a main graph. Every own implementation has its own naming for these kind of things. And this will also work very well if you don't have microservice but you have a monolith. You can just take parts of your models, create a graph for it. Maybe one model can have its own graph, or maybe you have one graph for your entire monolith. And these are also ways to bring things together. So you're not specifically tied to a microservices setup in order to get most value out of this. And as I said, merging GraphQL schemas can be done in multiple ways. So I'm saying schemas here, but you can see every schema can be a graph, and a schema can also have multiple graphs. So it's a way to think about. In GraphQL, everything is a graph, and typically you want to bring everything together in one graph. So you either have one main graph for your entire microservices setup, or all these services have their own graph that you will bring back merge together later. So you might have heard about schema stitching. So schema stitching was the the first way to bring together graphs, and this was first designed by Apollo, and then later they ditched it for federation, which I will tell you more about later on. But currently you can still use schema stitching. So schema stitching was one of the first ways to bring together graphs in 2015, 2016. Then Apollo ditched it in favor of federation, and I think since a year, maybe a bit more, the Guild has brought it back. So the Guild is an open source organization that works on a lot of GraphQL, a lot of different GraphQL tools, and one of the things they're doing is schema stitching. And with schema stitching, you actually write code to bring together schemas, or to stitch them, as they would like to say it. So this is part of a setup. So if you look at the top, you can see multiple schemas are being stitched. So this will take schemas from your product's API endpoint or product service, from a CMS that you maybe are interacting with. And then it can also take a local schema. And these will be stitched together using schema stitching. And then you can just pass this schema to a GraphQL server. So where you would regularly push a normal schema, this way you will push a stitch schema. And then something else you can do is create custom resolvers for these schemas. So imagine you have these three schemas that you see at the top. They will all be merged together in one graph, but maybe you also want to make relationships between different fields coming from different schemas. And to do that, you need to write custom resolvers. You can also use type stitching, but it doesn't work everywhere, and it requires no duplicate types to be there. So typically people write custom resolvers that will bring together information from different schemas, which is okay, but it does require you to write custom code in order to bring together these different schemas, which can be quite tricky because you already wrote resolvers and schemas for your microservices, and then you need to do it again with schema stitching. So often I see people starting with schema stitching for the microservices and then ending up with some sort of a monolith approach after all, because their gateway becomes somewhat of a monolith to the underlying services. And then, as I said, you also have federation. So federation was introduced by Apollo, I think somewhere around 2018, 2019. As a follow-up for schema stitching, because schema stitching revolves writing a lot of custom resolvers. They came up with a federation which is a little bit different, so it helps you to bring schemas together at the schema level instead of at the resolver level. So what does it look like? Typically looks like this. So you would need to write a Apollo gateway, and Apollo actually introduced Federation 2 a couple of weeks ago in a stable version. And with federation, you bring together different schemas. As you can see, they are defined here at the top. So you would write some sort of a super graph here, where I bring together multiple schemas, and they will be merged together. And at the schema level, you can make the connections between the separate things. So you don't need to write custom resolvers. Instead, you add custom directives to your schema. That will help you to bring together information from different fields. And then the super graph is something you will just pass to a GraphQL server. And this GraphQL server can be, should be built in Apollo if you tend to use this setup. If you're going with schema stitching, you can basically pass it to every GraphQL server instance that is out there, because there are multiple ways to build GraphQL servers. As you might know, you can use Apollo, but also the Guild, which I mentioned, has a lot of great tools. I see Nearform is also building their own tools with GraphQL Mercurius. So there are lots of great tools out there. And this can also feel overwhelming, especially if you're not that familiar with GraphQL yet. You don't want to invest all this time in building GraphQL servers, in writing resolvers, because you probably are new to all these different things. So there's also a different approach to this, which also starts again at this setup. So if you remember, we have a microservices setup, we have an authorization service, we have a user service and a post service, and they all have their own domain. As you can see, the domain is authorization or authentication, then it's users, and then it's post. And in order to fill your client, you will need to interact with all these services. And as we can apply GraphQL to this, we can also bring together the schemas for this. And for this, I've created a demo, which before we try it out, I will show you what will happen. So you have all these different microservices that are using REST. Maybe you're already using an API gateway to bring them together. But using GraphQL, we're going to create a schema for every microservice. So every microservice will become their graph. And if you have distributed teams, every team can maintain their own graph. And for this, we'll be using StepSen, which can be used in two different ways. But basically, you can connect any backend or data source. So it can be a database, it can also be a REST API or a GraphQL API. And as we have REST microservices, we'll be connecting to a REST API. So we can do this either using the CLI, which I'll show you in a bit, or by writing GraphQL schema design language. So earlier I told you about different ways to combine GraphQL schemas. With StepSen you can use either a CLI or a GraphQL schema design language, and the CLI will also write the schema design language for you. But the idea is here that you just create a GraphQL schema, and in that schema you will use custom directives to bring together data from different sources. So it's a bit like what Federation does, except it doesn't require you to write a gateway by hand. And then it's important to think that all the microservices are graphs. So if you create microservices, they're all graphs, and you need to bring them together at some point. And then we're going to merge the schemas with GraphQL schema design language. But for this, let me first show you the demo I've prepared. So I've created something quite basic. I think this is large enough. We have all the different services here. So we have an authentication service, which is, well, nothing too fancy. It is just a endpoint that will give you some tokens. And then I've created a posts microservices and the users microservices that you see all here. And I will share the link to the repo with you later, of course. And what we can do here is we can just start the different services by running npm start, which will then take all the microservices and start them at once, and then it will deploy them on a endpoint. And of course, it also has authentication. So let me go to this example and get rid of the authentication for now, so I can show you what's going on. So we have all these different endpoints that are deployed on a local tunnel. So I'm using local tunnel for this, which is quite a nice npm library. So if you're interacting with a front end and you don't want to work with a local host, then local tunnel will really help you do this. So this is one of my simple endpoints. I've created one for posts. Then I also have an endpoint for users. And what they will be doing is just return data from a db.json file. So I created a very simple microservices architecture that will still work, of course. And they will all use the same authentication service. So as I said, if you want to add GraphQL to this, you will need to create a graph per service. So let's suppose you have the post service, which we can see running here. You also have a user service, which is running here, and it will have also a very small setup. It just returns you information about users. Just as posts, it can also take params, so we can go to post number 1. I think we can even do some querying, but I'm not sure how that works anymore. But at least you can make different relationships. So you can get all the posts, or you can get a single post, and the same can be done for users. So if you would change posts for users, you can still get the same information. And then all these different services are running here. But then I can also, of course, add GraphQL for any of these services. And for this, as I mentioned before, we can use the CLI. So if I would go, an example, to the post services slash posts, which is running on this endpoint, I can transform this into GraphQL, which I've already done manually by hand, but let's use the CLI to automate this for us. You just run StepSen import curl, as we're importing a REST API. And then I can just import it like this, which will actually fetch my endpoint and then create a schema for it, which will be generated in this file. And then you can see it as all the fields that we have for the posts. So you can see it's called my query. It has this endpoint that we provided to the curl request, and then it auto-generated these types for me. Because if you look at your response from the JSON, you can see there's ID in there, title, image, and author, which is the way we link it to users later on. This is all generated for me. You can of course also clean this up by using some CLI flags, because my query name is not really a nice query. So let's change query name to get posts, and then an example, also change the resolve type to query type, because we are getting a post. So this will then again generate my endpoint if I still have it running. Looks like it doesn't. It changed the endpoints here, so let me take this new one. Go there. Yeah, so this is where my code is running now. So I actually set up local tunnel, but I've linked it to NodeMon. So every time I will save something within these files, it will refresh, which is kind of nice if you're developing something, but is also sometimes a bit annoying. So let me go back to my CLI here and change the endpoint to be using this host from local tunnel. And then, get rid of this part. So now it will generate the schema again, but instead it will be using nice names for my queries and my resolve types. And this is of course all very nice, but I already created the schemas manually. As we're working with a different setup, I wanted to make sure to have variables in here, like a host name for every different service, which I can then bring together here. So let me get the latest host names for every service. Just paste them in. So this is my authentication service. This is my post service. And then this is my user service. And just save this. It's important to keep things running. And then if I would go back here, I can run steps and start in order to start my GraphQL schema. And this will combine all the different schemas that I've created by hand, but which you can also create using the CLI. I would be going to this endpoint, which I probably have opened here already. Yes, you can see multiple things. Let me zoom in a bit. So it has all the posts that I either created by hand or created using the CLI. And then I could just query them. But the first thing you always need to do, as I have microservices, I would need to get a token. So this is always the first step. You should get a token using your authentication service, because every microservice will need this token in order to validate. So after getting this token, I can then get, in example, my posts information by using the post one. Just make sure to paste my token in here. This information as well. So using this token, I can also get the posts, and then of course I also want to get user information. And users here as well. Token, maybe get the first user, as that one is linked there, and then get some fields like an ID and name again. So this is the same setup you would have if you would have working with REST microservices that we just transformed to GraphQL. But then of course you also want to bring data together. So before every request you don't want to manually get the token, because that will be really time intensive. So what I can do by bringing schemas together, I can also write queries that collect information from multiple queries at once. So if I would be going back to my schema, which I've generated for the posts microservices, what I'm doing here, I have of course the query to get post information, but then I also have a query that's doing a sequence, which means it will do multiple queries, and then will return you the types of the latest query. So this sequence will be doing two steps. It will first get your token, and then it will query the posts. So instead of manually having to do this process of getting a token and then getting posts, I can also just do get posts, which will then get my token, and then I can still return these fields. Prettify it a bit and get rid of these things because I no longer need them. So this will do a sequence of steps. It will first get my token, and then it will the response of the token query will be inputted as a query parameter for the information to get the post. So this way I'm stitching the schemas together because I'm combining both my authentication service and my post service. So this is a really nice way of bringing schemas together. And basically every implementation of GraphQL schema stitching or federation can help you do things like this. And then it's even possible to do more complicated combinations. So this is a very straightforward one. For users, you can do the same thing. You can also bring together user information with post information, which I've done here. But let me show something different, because I've also created something like a super graph. So instead of changing all the individual graphs of your services, you can create a super graph or a data layer graph and then do multiple things at once. So an example I've created here, one that will get, first it will get my token, then it will get my user from my user services, and then it will do even more things like getting the post by user, and then even collect all the information from these different queries into one response. And the possibilities here are basically endless, and it will really help you to transform business logic that you will maybe implement to your client. Because if we go to our previous setup, we had a setup where we were calling different REST API microservices from a client, which require you multiple round requests. Instead, you can create a data layer or an API gateway for these services that will collect this data for you. And then from your client, you can only do one request. So if we would go to your query. So this is basically something you would just send over HTTP. Because GraphQL, and as people aren't that familiar with it yet, I can show you what's going on. So every time I would send a request here, it will just ping my GraphQL endpoint. To give you some background. So GraphQL it's just an API protocol or specification that runs over HTTP. So sending a GraphQL request isn't that different from sending a REST API request. So we just have one endpoint, because GraphQL is just one endpoint instead of multiple, as you see with REST. You always use a post method, which can be quite weird at first, because GraphQL is only supporting post. You might have some headers, you might have some request headers. But the thing here is your request payload is the most important part, because GraphQL is just HTTP, and the query, the information that you're requesting, will be sent in a post body. So that's why every request is a post. And in there you will just send your query, which you then of course need to encode using JSON. And this is just a request. So you can also send this request over curl or using Postman or whatever you prefer. And also from your client you can use a GraphQL client, which is helping you to do a lot of transformations from your request, but you can also just use a JavaScript fetch method and use the endpoint from the GraphQL API, use a post method, and then just append this post body. And then the response, it will always be JSON. So GraphQL APIs will always return you JSON, no matter what the underlying thing might be. It can be a database, it can be a REST API endpoint, it can be a different GraphQL API. The response of GraphQL will always be JSON. So from your client, you can just use this, and then the GraphQL Playground, which you're seeing here, is an interactive IDE that will help you build GraphQL queries. So you saw me using this Explorer. It will show you all the different queries. But from this GraphQL Playground, I can also explore my schema, which is also a convenient way of doing API documentation. So imagine every team is maintaining their own microservices, they're maintaining their own graph. So if I would go to this schema, you can see if I query, every team will have their own queries that they will add to the main graph, and then every team will also have their own response types. If I was looking at posting example, the team responsible for maintaining the post service can change these fields, and then different teams that want to implement this, they can use this IDE in order to see what type of fields are available. And then if another team is maintaining the user service, they can also just maintain their own response types and keep them in here. And then if you're sitting on the front end of the part, or maybe you're sitting in an integration team, You can bring together all these different types by using GraphQL and then being able to query all these different fields, which is a nice addition because otherwise you would need to use all the different microservices. You need to introspect them, you need to find out what type of documentation they have. And if you have a small company, that's fine. But if you have a large company, maybe one team is maintaining the documentation for the service quite well, while another team maybe isn't doing this. And what is also a benefit is maybe one team is building a service in REST, while the other team is using gRPC or is using GraphQL. By using a GraphQL API gateway or by building your own data layer, you can bring together data from services that use different protocols as well. So the setup I showed you is a setup with StepSen, but you can easily transform this out for schema stitching in case you want to build your own GraphQL server that resolves all these different underlying services, or use federation as well. Most libraries that you can find out there can help you set up either of them, but the concepts are the same, and also the way of implementing it is almost the same. There are some subtle differences. With StepSen, in example, every time I run StepSen start, it will already deploy this service for me to a cloud. So you no longer have to maintain your old build pipelines or need to set up things like this yourself. So looking back at what we've done, what you can basically do with every other implementation service. So if we go back here. So you can use schema stitching as we've discussed. So with schema stitching, you would still need to create a graph for every different service. You would have your graph for the authentication, for the users, and the posts. You would need to define them in this method and say, I'm stitching schemas here. And then if you want to combine information from different ways, as you saw, I've combined the authentication request with the post request. You would need to write custom resolvers for this, which can be very time consuming. With federation, it's a bit easier to bring together these schemas, so you can you still need to define where all your subgraphs live, so you still need to define a graph for every service, and then you need to merge them together using this introspect and compose method. And then if you want to combine information from different schemas, you can also use custom directives. And the catch here is that you need to make sure that every service or every graph you're building for your different microservices need to be able to support Apollo federation, because it will require some extra queries that are needed for Apollo to know which fields and types are available. And then of course you need to run them as a server yourself. So you need to make sure that the output of this will run on some container or run in some cloud somewhere. And then with StepSen it's a little bit different because, well, you can either use the CLI to import your different endpoints, and you can append headers or other curl flags to this, or you can write your own GraphQL SDL. So you don't need to write custom resolver code. Instead you use custom directives like you see here to point the GraphQL schema towards where your data is coming from. This can be a REST API endpoint, but as I mentioned, it can also be a database or a GraphQL API endpoint. If you watch the keynote from this morning, they were using PlanetScale. An example, you can use StepSen together with PlanetScale and then introspect their MySQL database and generate a schema for you automatically. So this can be a convenient way of building either using the CLI or using GraphQL schema design language. And then to merge the schemas, with every setup you will need to create some sort of data layer or API gateway that brings together all these different services into one unified GraphQL server. And this can be either one you build with schema stitching by building custom resolvers, or using federation or StepSen to declaratively build a data layer for you using GraphQL schema design language. And then with StepSen, you have the added benefit of deploying it for you in the cloud. So if you want to find this example, it is on this GitHub organization. Also, if you have questions, we can use the time now. Maybe we have some questions from people watching remotely as well. And I'll be around for most of the rest of today in order to help you answer these questions. So thank you. And if you have any questions, then now it's the time to ask them. Yes. Mm-hmm.
but I saw you were using like a special property called access token within the GraphQL.
Yeah.
How does it work? Like a reserved object to only be used to pass HTTP headers?
No, not really. So let me repeat the question for the remote watch. So the question was how you can pass HTTP headers to a GraphQL API endpoint, and there are multiple ways to do this. So this depends on how you implement your server. So what I typically see is if you would have an underlying REST API endpoint, you can pass the access token as a query parameter to your GraphQL API, and then this query parameter can be passed to your REST API endpoint. What you can also do is GraphQL APIs will also take HTTP headers. So you can also send your token to the GraphQL server itself that can then parse it and send it to the underlying services. So there are multiple ways to do this, and it really depends on your implementation. There's no set guideline for this. Typically, if you would send it as a HTTP header to the entire GraphQL API, you need to parse the token at a different level than if you want to send it to a query directly. So if you are using different services underlying, it's typically easier to use query parameters instead. Yes.
I was wondering how easy it is or how complex it is maybe to export from GraphQL types
Mm-hmm.
in TypeScript fashion.
Yeah, so the question was how you can export a GraphQL schema or types in GraphQL to TypeScript. It is quite easy. There are multiple tools for it. If you're using Apollo, Apollo has their own TypeScript code generator. And then there's an open source one called GraphQL CodeGen, which is quite cool because besides besides changing your GraphQL schema to TypeScript types, it can also help you generate code for different GraphQL clients. So as I mentioned, you can query GraphQL using just a fetch request because it's HTTP. But there are also GraphQL clients out there that can help you with caching or will give you an easier way to send a query to a GraphQL server because you need to do some encoding using JSON. So with GraphQL Code Generator, you can generate types for your entire schema and then also for your operation. So you can define a file with all your queries, and then these queries can already be transformed into response types for your client. Yes.
So I've used that code before and it is really good, but would that code generator work with your extra like schema keywords and stuff that you put in via steps then? Would it still work?
Yeah, definitely, because with steps you define a schema, but the schema you define in your IDE or in your local environment, it's a bit different from the schema that will be deployed because the deployed schema won't have the directives in there. So basically, all the implementations will strip out any custom directives and then we'll deploy the schema without the custom directives. Yes.
So if you're moving to a GraphQL setup, where does business logic that's not data related live? For example, you create a new user, you put them in the database, you need to send them an email, maybe you need to
Mm-hmm.
queue up something for processing somewhere else. Is that still behind other REST API calls that you're calling? Or?
Yeah. So the question was how to move from REST to GraphQL, and then what you would do with side effects, right? So if you add a user to a database, how would you handle sending an email or a text message or whatsoever? So that business logic is the same as you would do with any REST setup. You can either use a different query for it and then sequence the queries, or you can have a REST API endpoint for it that you would then link to a query and call it. So the setup is basically the same. So any side effects or business logic, it will be handled in the same manner. And if it's a different service, you will need to make sure that you can access the query from the different service as well. Okay, let me see if we have any remote questions. I see one question about GraphQL schemas. So in the GraphQL schema, you can use the exclamation mark to define if a type is required or not. So if you are generating code for TypeScript, I've done some different talks about using GraphQL with TypeScript. There are some differences between the two type systems. So I would advise using a code generator to create the types for you, because in GraphQL, every field is optional unless you set is required, while in TypeScript it's the other way around. So when designing a GraphQL schema for maybe a TypeScript microservice is something to keep in mind. And then I think those were all the questions. So, well, thank you for your time. And if you have more questions, I will be around most of the afternoon. Or you can also find me on Twitter using the handle @GetHackTeam. So thank you.